cloud. I mean, I'll post it completed, but I'm not going to do 4 with you, okay? Again, why am I not going to do it, you ask? Because it's just more practice. This is just reiterating factoring. So on this one, you can't do simple factoring. You have to actually go through and do grouping or Xbox after you split the middle, whichever one you, on the numerator. So the one in numerator, you have to either do one or the other. I don't care which one you do, but that's what you have to do there. And then the one, what am I thinking here? On the bottom is pretty easy, right? What multiplies to give you -2, but adds to give you -1. And this is just practicing, analyzing. And the goal is that you're going to see that one can be eliminated. If something can be eliminated, it creates a hole, right? And around that hole determines my behavior, okay? That's the gist there. Here, this is the main part of the next part, is being able to work backwards, okay? So we have to be able to work backwards. If I'm given the graph, can I write the function that created the graph?
No. Yes.
That's the goal, okay? So when I'm talking about this, that means that you have your general form. I'm going to write it as g of x equals a, which is your constant, your coefficient of some sort. And then you'll have times your factor 1 times factor 2, ... right?
Yeah.
In some form or fashion, that's what's happening. Does that make sense? Okay, so when we look at this function and we're analyzing what's happening, our factors.
You can't laugh. That happened to you. Way worse. I can laugh. You can't.
Okay, you're okay?
Yeah, I'm good.
Okay, it happens to the best of us, so don't stress over it. It happens to the best of us. I said what I said. And we work backwards, okay? So we have to work backwards to find the given information. So here, we know that we only have one intercept, right? We have one intercept at 0, 0. Even though it's not highlighted, there is a horizontal asymptote at 0. Do we see that? Because what's happening at the ends, notice that these aren't crossing. My middle may cross, but my ends are, or no,
But it does cross.
my middle is crossing. There's one point allowed for horizontal asymptote mathematically that can cross.
Okay.
But my ends, are my ends crossing?
Wait, so your x-intercept is a hole?
No, it's there. It's a point.
Well, why can't you go? Wait.
It does equal 0. At one,
I thought that was the asymptote.
you can cross. Remember, it's not as permanent as the vertical.
That means the y-intercept is also 0, so like there needs to be no like where they're gonna cancel out.
No, it's a value. You're 0, 0.
Yeah, but like when we're looking at the equation, the like c value in the equation, there's not gonna be one.
Because it's nothing being added. So once you start, now you're going to work through figuring out what is what and where are things falling.
So to have we have to have
So the numerator and the denominator have to,
the numerator smaller,
the
right?
numerator has to be smaller. So we know that the degree of our numerator has to be smaller than the degree of our denominator. We know that we have vertical asymptotes, and this is because we have a y equals 0 horizontal asymptote.
So we know we have to have x minus 2, x plus 2.
We know because of our vertical asymptotes at x equal -2 and +2, that our factors in our denominator have to be x minus 2 and x plus 2.
And so we only have one factor in our numerator, right?
It has to be smaller, exactly.
And that's our
Okay.
y-intercept with the
Your y-intercept is just a point that you can use to help someone.
intercepts are your numerator, right?
Yes,
So that means it's x in the numerator?
because it has to be a 0, right?
So that's it? Is that really it?
So now, putting all the tools that we found together, because we're at 0, 0, we know that in our numerator, it only is x happening. Okay, in our denominator, we have x minus 2 and x plus 2. So far, are we satisfying everything that's required?
Yeah.
The degree of our numerator is smaller than the degree of our denominator. We have our vertical asymptotes present, and we have x.
Is it smaller if it's the same? No, because you have two x's in the
One.
numerator, they will plug together to make it squared.
So the degree is smaller. Okay, the last thing is checking your end behaviors, okay? So are my functions ending correctly? Are they behaving positive and negatively? Okay, so your leading coefficient, is it positive or is it negative? The way to test that is by choosing your point and determining what's happening. So if we chose, let's say, 8. So 8 on this side, if I plug 8 into here, am I gonna get a point that is positive or negative? And what did I need it to be? Negative, because it's below the x-axis. If I plug, and then that's just the gist of it. You just have to work backwards. You're undoing everything in the middle. And it's usually through an intercept. I can't hear you. Hold on. I don't know what he's gonna say, so I'm gonna stop this recording.